In this short video, I'm going to talk about different physical characteristics of a trapezoidal open channel. All right, this is our trapezoidal open channel. I'm going to say that this is the surface of water. I'm going to show it like this. We have the bottom width of the channel. Let's define it as little b over here. And then we have the top width of the surface of water right over here. I'm going to define this as capital T, and this is the top width. What else? We have depth of water. This is depth of water. We usually show that using little y. And then the last thing that I want to define over here is the slope of the sides of this trapezoidal channel. We normally show the slope like this. So this side is normally 1. We call it the rise of the slope. And here, we usually show it using m. And m is the run of the slope. So m is the run, and 1 over here is the rise of this slope. This is the convention to show the slope of the side of different channels. All right. Now, using this variables over here, these parameters, we want to calculate wetted perimeter, area, and top width of this trapezoidal channel. All right, let's start with top width. So, all right, should be very easy. Let me change the color and quickly show you that I can divide basically this trapezoidal channel into a rectangular area, rectangular part, and 2 triangles, right? So if I want to calculate the top width, this would be the length of this rectangle, which is b, plus this section and this section. And these 2 sections are a part of this triangle and this triangle. Now look at this triangle over here, 1 over m, right? This triangle is similar to this triangle. And we know that this depth is y. So y and 1, right? This part would be my. And similarly, this part, we have another my. How do I know that? Because again, these 2 triangles are similar. And I can have the same triangle over here too. All right, so the top width would be b plus 2my. Why 2? Because there's 1 my over here, 1 my over there. All right, this is how you calculate the top width of your trapezoidal open channel. Let's talk about area. And when we're talking about area, we're talking about cross-sectional area of the channel. So area, or A, is going to be equal to. Again, what area I'm talking about? This area that I'm going over right now. We want the cross-sectional area of the flow. All right, this area is equal to the area of this trapezoid, right? We know the top width, we know the bottom width, and we know this y, depth of flow over here. So it should be very easy to calculate that. This is how I calculate that. So I have top width plus bottom width divided by 2 times y, which is the depth of the channel, right? And top width we calculated over here. Let's put it inside this equation. Times y. And then this gives me b and b, 2. And then I can cancel out the 2's over here. It would be b plus my times y. The last thing that I want to calculate is the wetted perimeter of this trapezoidal channel. What is wetted perimeter? So right now, if you take a look at this trapezoidal channel, this line that I'm going over, this is going to be the wetted perimeter of this trapezoidal channel, right? So let's write it down. We know this length is b. Now what we need to do is to calculate the hypotenuse of these 2 triangles. Let me show you. So we have this triangle. I'm going to show it right over here. We know that this length is my and this length is y. We want to calculate the hypotenuse over here. This is going to be This is going to be the hypotenuse of this triangle. Remember that we have another hypotenuse over here that needs to be added when we are calculating wetted perimeter. So I can take y squared out of this. Right? Okay, so wetted perimeter is going to be equal to b, bottom width, plus 2 of these hypotenuse, one for this one and one for this one. And this is how you calculate the wetted perimeter of a trapezoidal channel. Now, you're going to ask, how about hydraulic radius? Hydraulic radius, the definitions tell us that it's cross-sectional area of the flow divided by wetted perimeter. So you have the cross-sectional area of the flow over here, and you have the perimeter. This would be your hydraulic radius. How about hydraulic depth, or D? Hydraulic depth, by definition, is cross-sectional area of the flow divided by top width. We calculated top width over here. So again, this is going to be, and top width is right over here. All right. So in this short video, I showed you how to calculate different characteristics, typical physical characteristics of flow in a trapezoidal channel. Now, after this video, I want you to repeat these types of calculation with this type of logic for a rectangular channel and also for a triangular channel and see what you get.